Good evening, everybody. Welcome to my video. I got a visitor yesterday, actually from the guy that runs the machine shop that made the parts for my motor. Come over and dropped off some stuff that I might be interested in. A couple of power supplies, and then this thing here is the EMI filter. I'm not exactly sure. I don't know anything about electronics, so I don't know what any of this stuff is, really. Like this here, I don't know what this thing is. It's a silicone power block, power cube. Silicone power cube. So I think it's like a overinflated bridge rectifier, maybe? I'm not sure. Very interesting, though. And then this power supply here is, I don't know if you can see that there. This input to 105 to 130 volts, 57 to 63 hertz. So that's that one. And then this one here, another lambda. It's I don't think I can focus on that, but it says input 105 to 125 VAC or 210 to 250 VAC. And the max rating is 24 plus or minus 5% volts DC at 10.5 amps at 40 degrees Celsius. Interesting. It's got a nice big cap in it, though. I think it's a 50 volt. I might take this one apart. It's got some transistors in there and stuff, and some major heatsink there. Nice heatsink on this one here. Now this power supply here, see if I can get in there if you can see that. It says 120 volts VAC, 240 volts, that's the input. 47 to 420 hertz. And then the output is, looks like 124 volts. Yeah, it's kind of hard to see it there. It says there's a 1, it says 124 is punched in it, but only the 2 and the 4 are like marked or dark, like painted. So I don't know if that's supposed to be just a 24, or if that's 124 volts DC at 6 amps, it looks like. Interesting. But this one here, I think I'm going to keep intact because the input is 47 to 420 hertz. Now, I don't know if I can wind a coil that's going to give me 120 volts, like one of these power coils here. I guess if I wind like 1,500 feet on the wire, I could probably get like 120 volts. And then that thing, if it's running at 1,200 RPMs, and there's 6 cycles per revolution, that's 7,200, and then divided by 60 is like 120. So I don't know if that thing's running at 120 hertz or what, but whatever it's running at, I think I'm getting more than 47, and I don't think I'm getting more than 420, so I might be able to energize this thing with that and then convert it back to DC, 24 volts, make AC off of there, convert it to DC with this thing, and have some usable power at 24 volts DC. So I don't know if that'll work or not. That's a little further down the road. I'll hang on to this one, though, that's for sure. But I think I might rip this one apart. I wish I'd have got these things earlier. There's a lot of good wire in there I could have used, but that's okay. I got new wire, so I can wind coils to my heart's content, I guess. So, and then I don't know what this cap. I think that was maybe that was the 50 volt cap. I should take it out of there. Maybe I'll take it out of there and show it to you when I get it apart. So that's my haul. It was nice enough to drop it off for me. It's just had it sit down in the basement of the shop over there. So um, he's getting rid of a bunch of junk over there. So I told him, I said, if you got anything over there that you might think I could use or play with or just enjoy, no sense in scrapping it. I'll take it. So he brought this stuff over for me. So that was really nice of him. Well, I guess that's it for this video. If anybody has any idea of what these actually are and how I could possibly use them, it's got the schematic on there. Interesting. Yeah, let me know if anybody knows what those things are. Anyway, I couldn't find a data sheet on them. I searched for a couple hours on the net there, but I couldn't find anything that gave me any information. I found some of these here on there. Actually, I found that exact one on there. I guess you can still buy those. So, but that is an 6 VSK1. So I don't know if that, it's 6 amp, 120, 250 volt, 50 to 60 hertz is what it says on there. Says I guess the output is 5 amps at 40 degrees Celsius at 250 volts. So that's interesting. So yeah, lots of fun. Big transformer there. Let's see, this one here is 230, 115, and then all the wires are cut off of here. But I guess if I want to use the transformer, I could always rewire it back up. But yeah, I don't know about that one. I'll hang on to them though if I need wire or something like that, or some ferrite material. Got some there. So I don't know. Maybe if I do rip that apart, I'll save the ferrite material out of the transformer there and maybe make a ferrite cord for testing, just to test it, because I know that it's magnetic and it slows the wheel down. It takes a lot of energy to overcome that magnetic pull, and with this type of motor, I believe works better without a core, without a magnetic core. Now I want to try aluminum core in here, and maybe brass or copper core, something like that. And then there's also some plastics that are that you can quench with a flux field. So they're like dielectric. They have dielectric properties, I guess you would say. I'm not exactly sure exactly how to explain it, but I'm thinking maybe you can do that get the same flux quenching effect with a plastic core if you use the right type of plastic as you would with like aluminum or something like that. So I don't know. I'm going to try it. We'll find out together, I guess. Hopefully. Keep going here. So everybody seems to like the videos, and I really enjoy posting them, and I like watching everybody else's videos, and we're all kind of learning this all together. So we'll just continue, because it's a lot of fun. Gives me something to do. So lots of fun. I can get back on my circuits here, get those swapped around like I wanted to do. I was busy yesterday, running around. We opened the casket up and pulled the magnet out, the broken magnet that we took out of the rotor there, and So that was interesting. We took the bigger chunks and wrapped them in electrical tape for two reasons. One, the pieces where they were broken off at were really sharp. And two, uh, I wanted to hopefully capture the material breaking down and, you know, keep it inside the tape there, and down the road, maybe one of these days, we'll peel the tape off and see if there any further deterioration took place, because where it's broken off at, where there's little crags along the edge, the broken edge, it just keeps flaking the pieces off. They just keep slowly popping off. And if you look in the video there, you can see a nice little pile of neodymium dust. And we took a magnet, or a baggie, and stuck one of the magnets inside, one of the pieces inside a baggie, and then just picked up the dust. It just sucked right to the magnet wrapped in plastic, and then we just pulled the plastic baggie off, and like inside out, kind of, and just threw it in the trash. That took care of all the dust. So it was relatively safe. I was kind of worried about it flying and taking an eye out or something like that, but you know, we put it out on that steel countertop, and all the pieces just stuck right to it, so we didn't have anything flying around anywhere. So that was good. So now we got like 3 big chunks of neodymium for playing with. So my buddy there was helping me with the casket there. He really likes magnets too. Lots of fun. So I gave him the pieces. He likes to play with them. And I also hooked him up with that big one that wasn't broke, but it had the bulge in it. The second one that I took out of there just before I did when I did the tear down video. So I hooked him up with that one too. And he really likes those things because they stick to something and he can't get them off, and he thinks that's fun. So we have lots of fun with the magnets. So, okay, well, I guess that's my video. I went on a little longer than I wanted to, just showing you this little bit of stuff here, but I get to blabbing, I guess. So, well, I guess that's it for the video. Have a wonderful day. Peace.